Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and I'm joined as usual by Nik, founder of Postgres AI. Hey Nik, how's it going?
Hi Michael, everything is all right. How is your business and life?
Yeah, good. We're in spring in the UK and it's just getting a bit warmer now. And yeah, business is good, ticking along. I've got some upcoming news soon actually that I'll publish in the newsletter.
That's great, yeah, looking forward.
How about you?
Yeah, obviously I'm a guest today, right?
Yeah, what are we talking about?
We talk about queues again. Queues in Postgres. My favorite, remember I told you so many times, I like to observe how many of them are created and how many of them have issues. Actually, almost all of them have issues. Now I digged into the topic deeper, and actually I had surprises. My understanding in the past was not fully correct. And I'm going to confess today, like where I was not, like where there were gaps.
Yeah, and just to clarify, when you say that they all have issues, do you mean queue implementations inside Postgres or inside relational database or OLTP databases?
Yeah, so when we have a new client, for example, at Postgres AI, our most popular type of client is a startup without DBA who are on like RDS or Cloud SQL or Supabase, whatever.
Yep.
And they have issues because they have growth. This is my favorite type of client. And they bump into some problems. We have various tooling for health checking, and almost always we recognize one of a few patterns like log-like, append-only, unpartitioned huge table, or a table usually also unpartitioned, which receives some events to process, right? And they got updates, deletes, and if this startup is more mature, we see some like PgQue, for example. Or if it's smaller, usually nothing. And everything is wrong there, starting from heavyweight log contention, right? But also bloat and a lot of complaints.
Are we talking about like self-rolled queue inside the database?
Yeah, so like naive implementation of queue in Postgres. You can see it naturally just looking at pgstat all tables, noticing patterns of workload, a lot of updates and deletes, but also a lot of dead tuples and auto vacuum, if it's untuned especially, cannot keep up. But also if they have long-running transactions or other reasons to block Xmin horizon. We need to discuss it slightly deeper today. They will have a lot of bloat accumulated and all latencies suffer, and all this like piece of workload and this table, usually just one table, it becomes a hotspot. This is a huge reason for them to complain about how Postgres is bad. And I don't fully disagree. Like only who didn't complain about Postgres MVCC and vacuum, all like being headache all the time? Everyone did, right? So yeah. And I usually said, all you need is two things. And actually not only said, I came to some implementations of queues less naive and even helped them. For example, long ago, there was a project called Delayed Jobs in Ruby. And I added a couple of things like index, which was easy, like just missing index. But also I said, let's use skip locked for update skip locked. So you just don't need this heavyweight log contention when multiple sessions compete to update or delete the same row, right? It's quite straightforward. And to some others, I had said always like, you just need two things, skip locked and partitioning. And as I understand, this is where everyone went. So skip locked created roughly 10, 11 years ago, actually 2015. I think it was Postgres 9.5, right? Because it's 2015.
Yeah.
And it's a great feature to get rid of heavyweight log contention. But it's not enough, right? It doesn't solve the bloat problem. Actually, somehow I noticed in my recent work over the last few weeks on Hacker News discussions and some other places, I noticed people think that skip locked will solve their bloat issues, vacuum issues. It's not so. So partitioning and skip locked is quite good enough, and this is where everyone went. I think PgQue, actually all modern queue systems in Postgres, they love skip locked. They are like all about skip locked. At some extent, my AI bots started, we did a lot of research, did a lot of experimenting, benchmarks. So at some point I noticed they started to name all these guys skip locked architecture somehow. Sometimes I don't like it. I like more update delete architecture. So update delete queue systems, not skip locked systems, because skip locked, it's shifting too much attention to itself. But skip lock is simple thing. Just let's get rid of heavyweight lock contention. That's it. Other problems which are bigger actually and harder to solve are not eliminated. They can be only mitigated with partitioning and rotation. And I saw, for example, PgQue, it's quite popular. I think this is a good legacy from Tembo.
Yeah.
It's supported, I think it's supported on Supabase, quite popular there. And they actually also went to get rid of the need of create extension, so they re-implemented it fully in PGSQL.
Oh, wow.
And then inform like trusted language extension, PGTLE, trusted language extension. Since it's purely PLSQL, you don't need to ask provider to support it. If provider supports PGTLE, you can have it. And not only load it as only SQL file, but you can have it as tracked extension without provider support because it's just PGSQL. So they also focus on skip locked, and they have support of partitioning, but it requires PG-Partman and additional effort, right?
And so, just a question on their partitioning. Is it like time-based partitions and you detach and drop them over time, or is it a rotational thing? Like
I don't remember, but it doesn't matter actually. So like what matters here, you cannot rotate partitions every minute. It's not practical.
Sure.
And it will lead actually to some other issues. So partition rotation should happen less often. And by the way, those who use partitioning to mitigate bloat, it's a great idea, but instead of attaching partitions, which I see in some queue systems, better to have several static partitions. I mean, stop creating them. It will lead to catalog bloat eventually, right? And also attaching has its own issues under heavy loads. It's better just to truncate and have rotation, like round robin of partitions, and you just truncate them and that's it. So it's much better in many senses. And this is what PgQue does. So I always said like these two things are enough, but I realized that they are not. That's the like.
Yeah.
My
Can I just
position. Yeah.
PgQue? When you say PgQue, are we talking about your new tool, PgQue, or PgQue the Skype-based original? Because just the letters PgQue.
Let me explain how it all started. So on our podcast, I was saying, that's it, like just skip locked and partitions, rotation or something. Skip locked felt natural because this is how we solve heavyweight lock contention when you have multiple backends competing to update or delete the same row.
Yes.
Inserts cannot. The inserts don't need it. They are independent, right? But updates and deletes, they compete. And when I said partitioning, I always said, look at PgQue Skype created 20 years ago.
Yes.
And that's it. And I thought it's enough. I thought Skype didn't have it. I mean, Skype didn't have skip locked that time, right? So I was thinking they did it differently because skip locked didn't exist in 2006 and 7. PgQue was created exactly 20 years ago, 2006, and it was open sourced in 2007. And now I'm talking about Sky Tools PgQue, right?
Yes. But it didn't do skip lock because it was also not doing updates or deletes, right? Like it was
exactly. We will come to that. We will come to that. But I was thinking, I had a false impression that we should use skip lock because it's modern path, but we also should mitigate bloat issues, vacuum problems, and so on, just using partitioning and rotation. And coincidentally, this is how all current guys are doing it. River, PgMQ, QUE, others. There are many now. And also, some of them are quite agnostic to languages. Some, like River, is Go oriented, so they're focused on Go frameworks. And that's it. And then what happened, actually? So this is my understanding 3 weeks ago. Then what happened? I was in Zion Canyon on campground, and they have good connection, actually. I was in my tent, and I saw that it was Friday evening, I think, and I saw Plain Scale blog post.
Yeah.
Right? And I started to read not a blog post itself, because I quickly realized what it's about. I started reading discussions of it on Twitter, on X, right?
Mm-hmm.
So that post was dancing around Brandur Leach, right? Who is actually one of creators of PgQue.
Mm-hmm.
So Brandur had a post in 2015 about basically how challenging it is to have queue in Postgres because of MVCC, and if you have long-running transaction with XID assigned or repeatable, I think Brandur used repeatable read transaction lasting 1 hour or half an hour, I don't remember. And I think in his post it was like below 1,000 events per second inserted, like maybe 800, and quickly like something like 60,000 events were accumulated unprocessed by consumers because everything started to lag and so on. It was 2015. I think this is actually was a year when skiplocked was added to Postgres. Interesting, right? 2015.
Yeah, good timing.
Yeah. So PlaneScale discussed how bad it is. Not like queue in Postgres are bad, but it's bad to have long-running transactions or something which is blocking Xmin horizon, right? And they promoted their new feature, how to mitigate it, but mitigate how? Just cancel that, right? So they have some smart approach, like which traffic is more important, which is less important. In my opinion, what we created with Andrei, transaction timeout, is good enough for everyone as default solution against long-running transactions, although there might be other problems like unused or lagging logical replication slot, right?
Yeah.
It can be, or maybe someone is using 2PC and prepared transactions also can be a problem. Anyway.
So anything that holds Xmin Horizon and prevents the cleanup of dead top or like old row versions.
Yeah. By the way, we just released our monitoring, which is like front. When we say front, we mean monitoring with Grafana and Victoria metrics and Postgres inside everything. We just released with our new dashboard for Xmin Horizon analysis, and there are 5 possible reasons. And also Lawrence Albee very timely posted blog post about how he monitors AutoVacuum. I stole a couple of thoughts there and just implemented in dashboard, and it's already released and like it's free for use, Apache license, but it works much better if you go and become our customer because we have great new health matrix. I will blog post about it separately. Anyway, this is connected because Xmin Horizon, we also talked about it. Everyone monitors long-running transactions, but it's off. It's the wrong thing to monitor in this context. You need to understand Xmin Horizon being blocked and by whom. To unblock it promptly, because this is how you can put your River or PgQue or something down, actually. Not down, but basically lagging and having very poor performance.
Accumulating a lot of bloat that is not ever recovered. If it's not using I think that's the other thing that people don't realize is there's no recovering from that, because once that's bloated, unless you're using like the partition rotation.
There are several things here. First, it's a lot of dead tuples are accumulated.
Yeah.
Because Xmin Horizon is blocked, so dead tuples are created every time you produce successful update or unsuccessful insert. So it means, by the way, that we also can produce dead tuples if some inserts are failing. But this is very subtle. It's nuance. Like we can omit it, right? So regular approach, we always produce dead tuples. Tuple is a raw version. We agreed on our first episode that I say tuple, you say tuple, or vice versa. I don't remember. Anyway, tuple is a raw version, so old version becomes dead, but it's still hanging out in your everywhere, actually, including shared buffers everywhere, like It's polluting everything. So garbage collection called vacuum is needed to delete it. So it's two-phase process. First it's only marked dead and then it's deleted. And the first problem, a lot of dead tuples are accumulated. They cannot be deleted by garbage collection called auto-vacuum, right? And this first bad effect is latencies of consumption degrade very fast, actually. So because to find the next thing, you need to skim through all dead tuples with your index scan. And it becomes less and less performant. Yeah, next bad thing is that we accumulate big set of unprocessed events. Sometimes, not always. Sometimes, like we have degradation. And when I say degradation, it means like degradation was like 1 millisecond to fetch next event, for example, or batch of events. And then it degrades to second or few seconds. During 1 hour, I saw, I think, 5 seconds for some queues. Just to fetch one event, 5 seconds, can you imagine? It already, at some point, in some systems, if you keep inserting a lot of events and consuming them, at some point it might start timing out on statement timeout if you have strict statement timeout, as you should for all OLTP systems. We always recommend to have strict timeouts, right? This is, so a lot of the tuples degradation of consumer performance, consumer query. Second effect is a lot of them accumulated just because consumer capacity, throughput is not enough. Right? If you have, for example, 10 consumers working in parallel, skip locked help them not to fight with each other. And you have capacity, for example, to consume 2,000 events per second. But now suddenly latency became from 1 millisecond to 1 second, 1,000 times worse. It can happen during 10 minutes or so. And 10 minutes, just like, for example, you have multi-terabyte database. If you decided to dump it, right, or create logical replica in a traditional way, this is it. This is how you can reach second level of consumer query performance. And this leads to accumulation of unprocessed events. And for some queues, I noticed even when we stop a long-running transaction, we unblock Xmin Horizon. First of all, auto vacuum comes, cleans up dead tuples, immediately latency for consumer query drops. Yep. But for some, it didn't recover to previous level. It didn't recover to 1 millisecond level. It stayed like 50 milliseconds or so. I think it was Q, which is like QUE, very bad naming is mine.
I call it que. I call it que, like Spanish.
If you check, I'm not speaking Spanish, but who is speaking Spanish, how my tool is pronounced, it's crazy, right? Something like PgQue or something, I don't know. I have an issue, and actually I have already pull request to rename, but I didn't like all brainstormed names so far. PG Belt, this was the best I had, I didn't like it. And we will come to it, why PG Belt, right? And why Q actually is misleading, as I learned. I learned two big things during this journey, last 3 weeks or 2 weeks. So
just quickly, before we move on from side effects, I want, so eventually, even in a non-partition system, the heap bloat would get once the tuples are marked dead and vacuum comes along, marks it like reusable, new jobs or new events can go into that space in the table. But people don't, and I know we've talked about this like thousands of times, but it's the indexes that can end up bloated in a way that isn't recoverable without a reindex. So I wonder if that could be the source of the not ever recovering.
Maybe yes. Yes, you're right. And bloat might still be there. And this is what can be solved post factum, actually. It can be solved with partitions and truncate and in rotation, because truncate means like you will have fresh empty index and it will start growing from scratch. It's great. But again, I was thinking, first, actually, it's an interesting nuance as well. I was thinking, partitioning won't help in the middle of long-running transaction, in the middle of like when Xmin Horizon works. Actually, it will. It will help. It will help. You will switch to new partition. Old partition will keep old stuff with dead tuples, degraded indexes, and that's it. And this is actually, it will lead us to interesting optimization in my tool. But what it won't be possible to do, to have, I think it's possible, but I wouldn't recommend it, to have aggressive, like every minute partition rotation and truncation. First of all, you need a lot of partitions, maybe no, actually. Maybe you can find a way to to just jump between them. But it's not practical, again, because of catalog bloat and stress. When you switch to new partition, it's some stress and you need to clean up and everything should be processed. And if your dropped latency, like degraded latency, leads to unprocessed event accumulation, you won't be able to recycle, right? Old partition, because it still has useful data. You can move it to new, like it's becoming a nightmare actually. So anyway, it feels architectural wrong for me to have very often partitioning switch. Right, back to your question, time-based or size-based. Well, time-based is fine. I actually don't remember what I have in settings. I need to check. But here, your other question: are we talking about PgQue new or PgQue old Skype tools? So what I did, I took it as is. Right, first thing I did, I took it as is, and I just started to build around it. So I'm not touching core engine. That's the key.
So the original SkyTools PgQue core engine remains. Great.
So here's the.
I knew that, but not actually by reading did you see I thought it was a good blog post by Christoph Pettus covering the 0.1 announcement. Yeah, he's done it. He's been on a bit of a blogging spree lately, but he's done a blog post about PgQue or PgQue, your tool, already.
I missed it. It's cool.
Nice.
Well, what I wanted to say, guys, like there is alternative, forgotten kung fu, I say, because I know how trustworthy it is. 20 years. I used it in 2 of my 3 social network startups myself before I think it's a mistake, switched to RabbitMQ. I regret it now. Mm-hmm. We use it heavily. We use it even originally as Skype. Skype built it also not only like for event processing, but also to have logical replication. Instead of Slowney, they built Londeste, and it was working on top of PgQue. Native logical replication didn't exist at the time. So it was serving many purposes. And when they built it, Kafka didn't exist. Kafka created in 2011, I looked at. So it's called queue, but by nature, this is the second big thing I learned. It's not a queue system. It's a immutable log, similar to Kafka, not distributed like Kafka, or Red Panda, also modern thing, right? As I learned. And it guarantees that something is inserted, this is order, and consumer is just a pointer shifting, right? But it can be used for queue-like workloads, maybe not all of them, and we can discuss it in a bit. But what I wanted, I saw this blog post from PlanScale, and again, these discussions, like just use skip locked, and first thing I posted, and I found big feedback, like people like, yeah, that's it. I said, first of all, skip lock doesn't solve vacuum problems. It's just very wrong. Skip lock solves heavyweight lock contention, right? And also skip locked, there is another post from Lawrence Albe, select for update considered harmful, right? So there are issues with skip locked. It's a part of select update. You cannot use it without select update. And there are issues with that approach as well. The additional danger is there. But I wanted to show, like, there is PgQue from SkyTools, and we all know another tool called PgBouncer. And I'm wondering why, and I know PgQue is still used in very large companies as an important building block, very reliable, very performant. Skype originally built architecture for, as I learned from their talks, for 1 billion users. They achieved hundreds of millions. I don't know, after acquisition by Microsoft. By the way, Skype was closed last year. Also coincidence. So that's an interesting legacy here. And I'm thinking, why PgBouncer became quite popular, but PgQue didn't become quite popular. And my hypothesis is it's because of its extension, which requires additional daemon. And provider, maybe I'm wrong, but maybe providers just didn't want to bring any additional daemon, which is not a regular background worker, but something that needs to be managed separately. And
whereas PgBouncer is completely independent and...
Well, but that's a good point. It needs to be managed. There are some providers who provide it as managed service, but PgBouncer, it's like old tool solving that problem. Here, it's inside Postgres, and we need the additional daemon. I don't know, like I didn't participate in any of those decisions, but I just don't see any of providers supporting PgQue. Meanwhile,
maybe on Cloud SQL actually. Is it?
They support PL.
Okay.
This is maybe I told you this and I was wrong. I mixed it with another tool from SkyTools called PL Proxy. Cloud SQL supports PL Proxy. Yeah, and hello Hanu Crossing, who actually liked every single my post I think on LinkedIn about PgQue because he was from Skype as well. So it's great. And so then interesting thing, like I'm thinking, okay. You know my work, PgAsh, anti-extension concept, right?
Yes.
Yeah.
We talked about it.
Yeah. Then there are others, like I have a couple of more coming, but then I think, okay, I just need to repackage it, right? And being in my tent, I have new tool to create thorough specification, so spec creation tool, which I use for many things now. It's CLI, like just. And you start from idea and then explore questions, research, and then build a comprehensive tool, and then iterate with multiple LLMs, most powerful you can reach. And then you have already like version 7, for example, which is ready for implementation. So I wrote spec, how to repackage PgQue from Skype in this anti-extension manner. So no create extension is needed. And since like we discussed this, since we have pgcron, like with PgAsh, same thing.
Almost everywhere. Yeah.
Yeah. You need a ticker. So that's why that daemon was needed. You need a ticker. So PgQue, it's a log. There is a insert, can be single insert or batch, never updates, never deletes. And there is basically their own horizon. Like it's based on snapshots of data, right? So every consumer knows position. And to shift position, you need a tick. You need to announce, okay, we shifted because something new arrived. And by default, PgQue from SkyTools, it ticks every second. So it shifts and the consumer sees new data and fetches a whole batch of data events. Right? So batch is by default, like there. Batch processing is by default.
The thing I didn't understand is that you have a second table for keeping track of those.
There are meta tables, for ticking and for subscriptions. But Queue itself, it's 3 partitions, old school inheritance partition because it was created before native partitioning was created. Yeah. So 3 partitions, one is in work, one is like in the past, one is in future. And there is rotation using truncate. There is also delayed table separately. For those events which cannot be processed now, they need retry, we put it there. Yeah.
So that you don't end up truncating jobs that haven't been done.
Yeah, and it was a single table. I think I also implemented the same pattern there because sometimes we might have a lot of jobs to be retried, events to be retried for processing. So I created also 3 partitions. I also created dead letter queue for concept of maximum retries, and then we put it to dead letter, not to retry forever. So AI suggested this is like how many modern systems work. I said, oh, good idea. Let's adopt it here on top of what already exists. So I created spec. So I was like thinking, guys, I understand plain scale position. Let's just have a shotgun and fire all those long running transactions. Great. Transaction timeout also, that's shotgun. Maybe less smart, but still working and reliable, right? But let's just compare performance. I said, okay, let's compare performance. And I said it in the same session of Cloud Code, where we just created a spec. And then we started benchmarking, provisioned like, I think, 7 VMs in cloud for alternatives and PgQue. And I noticed it provisioned 2 machines for PgQue. One was original PgQue, and one it called like PL mode. PL mode. I was thinking, okay, what is PL mode? We're supposed to create it according to spec, but we haven't implemented it yet. It said, you created it in 2019. I said, okay, first of all, it was not me, it was Marco Crane, author of PgQue. But second, how come it's created? Apparently, meanwhile, also interesting part of the story, Alexander Kukushkin, maintainer of Patroni, in January, I think in PG Day Prague, I might be mistaken, presented a talk about PgQue, because PgQue is an excellent thing. let's revive it, right? Great, goals aligner here. I also want to revive it. And I was like, I told him, but unfortunately, you cannot install it on RDS, right? I was like slightly provocative. He said, no, my slides have a recipe. I go, how come you learned it? He said, everything is written in commit messages. The problem with PgQue always have been a lack of documentation. Everyone can tell it. I hear it 15 years and can say myself. So yes, indeed, there is a commit in 2019 or so to make it work on RDS and others. Let's have this support without a create extension, just a single file. Or maybe multiple files, doesn't matter. But PL only, PL PGSQL only mode. It's called PL mode internally in PgQue.
No,
so apparently it was already ready, but it was not. I said, okay, but meanwhile, I talked to my Cloud Code. I said, okay, but I cannot find that file. Where did you get it? I don't see it in the repository. It says, okay, you just need to run make.
What?
You need to run make to get this SQL file you can load to your RDS. We live in different worlds here a little bit.
Yeah.
I told Kukushkin, I think Gen Z won't understand us with this make. So I don't know. It's interesting. For me, it's like mind-blowing. Everything exists, but it's buried under these walls. For some people, it's not a wall. You git clone, cd, make, PSQL, import file, everything works. But imagine for some people, it's a big barrier, right? And
it'd be weird not seeing it in the repo. Yeah.
Well, you need to read commit messages, and that's great that Alexander has a talk promoting that this is possible. But it inspired me even more. Let's do it and add more and more in documentation. So my tool is just basically, it has it even as a module, and then it compiles and presents, this is our SQL. But of course, I started adding more things around. So this is it. This is the idea of PgQue with UE, which is universal edition, so it can be used anywhere. And I'm releasing this week second version with a lot of stuff, actually. A lot of stuff. Somehow, some requests and so on. First of all, I realized I need libraries. So we now have TypeScript, Go, and Python libraries. And one person promised to bring Ruby library as well.
Oh, nice.
Yeah, and I also already have 2 external contributors. So like I have some life. I achieved 1,000 stars in 4 days or so. It was good. I mean, it felt great. But I also learned it's not a queue. It's like a log. Because it's more like Kafka than RabbitMQ or ActiveMQ. And I agree after thorough understanding. That's why in version 2 I'm bringing another concept from SkyTools originally. It's called cooperative consumers or sub-consumers. So logically it's a single consumer, but there is a group of consumers which distribute load between them. This is needed, for example, when you have, imagine you have a queue of jobs like process some video. Some videos are super small, some videos are super large. In case of PgQue, if you just your position and read it by one, if you have, some people, by the way, looking at PgQue think, okay, if I'm adding more consumers, I'm increasing capacity. No, throughput won't increase because every consumer in PgQue reads everything. Everyone, everything. You need different queues to distribute load. It's like topics in Kafka, because it's actually not a queue; it's a log.
Yeah, but do you support multiple queues, or I guess it just involves creating
you can create
tables,
as many queues as you want. Every time they will be partitioned, and all the mechanics will work.
Yeah,
but with concept of sub-consumers, which is not my idea, it's a original idea. But I couldn't import it because it's a separate repo, PgQue co-op, and it doesn't have license. There are only 2 issues asking what license is it, because we want to package it as Debian package or something. And I couldn't take it, but I stole idea, of course, right? And re-implemented it with my own code. But the idea is the same. The feature is right now experimental. I need to play with it. And we started already benchmarking it and so on. It looks good. So this I think should be natively supported. So there is a lot of stuff, but the key idea is that now it's like a single file. You can load it. I also made it a PgTLE extension for those who want to properly track as extension.
Sure.
Right. And you just inject it. You configure PgCron. I actually thought about, and Hanu Crossing, who is now at GCP and Skype, we discussed it on LinkedIn and I implemented it. So PgCron cannot tick more often than 1 second.
I was going to ask you about this.
Yeah.
But look, your README says the default is 100 milliseconds.
This is new for version 2, yes. I just made it yesterday. Yeah. So I was thinking, first of all, people think about latencies. I recognize 3 latencies. First is producer query latency, how fast it takes to insert one event or a batch of events, like 100 or 1,000. Second is consumer query latency, how fast it is to take next batch fetch it, right?
Mm-hmm.
And we measure them and we see how badly the second one degrades for all alternative modern. I cannot name myself modern tool. I'm very old. This engine is 20 years old. So they all degrade. Here we don't degrade almost. We slightly degrade from 100 microseconds. We go slightly above 1 millisecond. While they from 1 millisecond go to 1 second, even sometimes 5 I saw. And degradation, we can discuss separately. Our degradation also solvable, but not solved into version 2 yet. When I say version 2, it's 0.2 because it's early, but it's super solid engine, we know. And there is third latency, end-to-end event delivery latency. If you shift your vision horizon only every second, it can be up to second at least. Also, a consumer itself might wake up not immediately, like you need listen notify or something. It's partially supported right now, but you need polling or something. You might lose some milliseconds there as well. And I was thinking this decision to have once per second was made 10 to 20 years ago. We have better hardware, so let's have 10 per second by default. And how? Okay, PgCron, which we rely on. By the way, PgCron is optional. You can put it to cron or something. You just need select ticker, PgQue ticker. That's it.
Okay.
Tick. Yeah, every second by default it was originally from SkyTools. It was in the first version. In second version, I made it 10 times per second, and it's simple. In PgCron, there is a storage procedure who has a loop with commit because we need the separate transactions actually to shift the snapshot. So so it's not every. This is same misconception as for \watch in PsQL. It's not every 100 milliseconds. If it's 100 milliseconds wait time, the operation itself also has non-zero duration, right? So roughly it should be fine, and like it ticks 10 times per second, but not exactly, like it's slightly shifting. But updating one row, it's super fast.
Yeah,
and it will be even better when I implement bloat mitigation for system tables, because this is why we go from 100 microseconds to 1 milliseconds or so under blocked Xmin horizon, because we accumulate the tuples in these meta tables, ticker and subscription. Yeah.
Are there any other downsides to increasing the ticker speed or decreasing the ticker frequency? Increasing the frequency?
So I did preliminary benchmarks yesterday, and important thing to understand: when it's ticking, if nothing to do, nothing to read. So it doesn't. And it means it's great if load is low, it won't produce new writes. But if imagine every 100 milliseconds you have new events. In this case, every time ticking, it's updating this row, which has its metadata. And we estimated it for ticking every second, it's 24 megabytes per second of fall. It's very rough because it doesn't take into account full page writes. So it's very rough. Just from ticking, overhead from ticking.
24 megabytes per second from a single tick per second?
Per day, sorry,
per day. That makes more sense.
Yeah,
that makes more sense.
And 240 megabytes per day. If you have right now default in version 2 to 10 times per second, which is acceptable. I mean, this means you have load already, right? So doing this database is loaded if every 100 milliseconds, there is ticking happens.
Yeah.
If it doesn't happen, again, no writes.
So it sounds like it scales fairly linearly then, like 10 times
This
more.
is overhead from updating this meta table with row where we are. That's it.
Yeah.
Right. So of course, if you inject a lot of data, there is mechanics there. Like interesting, might happen. And again, if you have long running transactions, Xmin horizon blocked, in this case, the tuples will accumulate, unfortunately, in system in metadata tables.
Yeah.
Which I'm going to solve also with partitioning and truncate.
So something I don't quite understand is when doesn't this make sense? You mentioned it's not really, it's a queue, it can be used for queue-like workloads, but maybe sometimes it doesn't make sense. Should we go into that a little bit?
This is a great question. I'm deep in database, so I would like to hear from backend engineers and people who build systems what's lacking here. One thing I can understand is lack of, for example, priorities for events.
Yeah.
Right. So because this is very linear, with cooperative consumers, I think the problem of big task blocks, small tasks will be basically resolved. But priority, I don't know. This is definitely not a pattern here. Also, if you need almost immediate delivery, PgQue or River might be better because they deliver faster, right? We have delivery end-to-end, I mean, end-to-end latency for job processing. What we have here is worse end-to-end latency controlled by this ticking frequency, obviously. I actually wrote a document about frequency tuning with some considerations. There is in docs folder directory, there is a special document right now. So the problem will be, so if you want almost immediate delivery, like for example, like it's, I don't know, like chat or something, maybe you should choose PgQue or River, but you need to fight Xmin horizon blockers very actively, right? And install our monitoring and connect it to our platform and check the health and so on and fight those blockers actively. What I can say is that update delete skip locked systems, they have better end-to-end delivery, but they degrade badly under Xmin horizon blocked. We have worse initially, but it's predictable, reliable, right? And in the case, if you have like background, for example, we discussed how to convert integer 4 primary key to integer 8 primary key. You have, for example, 1 billion rows, you need to change them. And you chose, for example, the approach I call new column approach. You create a new column with integer 8, and then you install trigger for all future rows already, and then you need to process your big backlog, billion tables. You do it in batches. How to schedule this processing? This is exactly any background processing where you like 50 millisecond end-to-end latency is fine. This is it. It's good. In work in batches. If you need 1 millisecond, okay, choose new tools, but fight Xmin horizon blockers. Right?
Yeah, I mean, my understanding of when you use queues is it's for asynchronous stuff. So I'm struggling to imagine something that can't cope with 50 milliseconds of overhead on something asynchronous. Even like a password reset, if it comes through a second later, is fine.
I agree. And in this case, maybe you should consider doing it outside of Postgres with different systems like Red Panda or something. Right? I can imagine some systems where you need very responsive behavior, but you need to learn how MVCC works and what dangers wait you if you build like that. You will have good latency in the beginning, but suddenly then something blocks you and then it degrades quickly. I wanted to mention that queue in database is great because it's ACID. Nothing will be lost, right? It's like it's replicated. It goes to backups. Nothing is lost, and it's isolation. All 4 properties are very followed, right? If you go and use different system, and you need to think about consistency, right? So you need to think about if you have something in database, you already wrote here but didn't delete that, or it can be inconsistent. These days, GitHub works very poorly, And since I posted this project on GitHub, I'm usually on GitLab. And I know GitLab issues as well because they are our clients many years. But they are great. On GitHub lately, wow, it's interesting. You already merged pull request, but it takes some seconds for counter to propagate. It's also for this pull request to disappear. So they have big lags in asynchronous processing, right? But lags are fine, eventual consistency, right? But data loss is not fine. So if you have data, I would say, if you need predictable performance, reliable approach, good throughput, not suffering from degradation when Xmin Horizon is blocked, PgQue is great. When you need much faster delivery and you want to stay inside database, ACID and so on, choose different system for Postgres, but fight Xmin Horizon blockers. And if you want better throughput, go with Red Panda, Kafka, or anything if you can afford supporting or paying for managed version. But in this case, do look at transactional outbox pattern. Right? Yeah. Because this is from microservices theory, so to speak. There is a pattern to organize data delivery from database to queue properly and all statuses. Like this is how you should do it, because otherwise data loss is eventually inevitable. Right? Yeah, this is how to navigate solutions. Advice from me. Yeah.
Right. Anything else you wanted to make sure we covered before we wrap up?
Well, I'm just excited that, among others, as you said, Christoph Petus, and also, as I said, Kukushkin, I guess we teamed up a little bit, not like somehow in distributed fashion, to shed a new light at PgQue, because it's a great piece of software. It solved problems before people encountered them, but somehow it got lost with knowledge. And I hope more people at least keep in mind what's possible and consider it building systems. And telling their AI to consider, because maybe just AI will look at it, do some benchmarks research and make decision. Right? That's it?
Maybe, yeah. All right, nice one. Well, thanks so much, Nikolai, and catch you soon.
Thank you for listening. See you soon. Bye.
Bye.